Let's talk about the slots for our user interface. Hello everyone, this is Ali Reza. Welcome to the Mentor Code Lab. If you recall, in previous episode, we showed the graphical user interface for our gem cleaner. We even drew out the fluid, drew out the progress bar and energy bar there. Of course, they are solid right now. They don't do anything. They don't have functionality. But one of the big problems that we have right now is that our block entities user interface has no slots, and at the same time, it doesn't show the player's inventory. Now, the player inventory is easy. However, the slots will need to be changed in future as we progress forward. The responsibility of producing the slots and handling the slots and their content fall on the screen handler. I will add few different things here and then we will move toward using our own library because honestly I have an abstract class that is handling lots of things like the quick move and we will talk about that inside this video. However, let's start with the player inventory. So we can say this dot player inventory slots. This is an internal class from the screen handler. As you see, it asks for the player inventory. We have it. Then we need the left and top coordinates. If we zoom into the texture, we have two different pixels that we can assign as the top left. One of them is this darker grayish color. If you assign it, things will not show up really properly. If you take a good look at the items in the slots and the slot highlight, you will notice that the slot is not in the proper place. However, if you choose this light gray color inside the slot, it will be the proper position. So the left is 8 and the top is 107. Let's add it. The X is 8 and 107. Now, if we run the game, we should be able to not only see some slots in the player inventory's position, but also we should be able to see the player inventory items in them. Okay, let's go into the game. Right clicking on the block. Not only we have a slots in the GUI, but also we see the inventory and we can move items from the player inventory into the block entities player inventory section. Now this is the player inventory. Okay, if I move this block here and I close the game and come back and take a look at my inventory, it's still there. The block entity itself right now has no slots, as you see. Now we want to add those things. To add a slot into a block entity, we can have an inventory. Let's say that we have inventory that comes from Net Minecraft inventory and we call it inventory. And let's say that we typecast our block entity into inventory. Now this will fail, I'm telling you, because block entity right now does not produce any inventory and any interface of the inventory's extension. Now let's add it here just to be safe. So I will say it implements inventory. We need to add method, and the method is size is empty, get a stack, remove a stack, blah blah blah. Okay, so let's get that. For the size, let's say that we have 1 2 3 4 5 6 7 and is empty, is false, get the stack returns null, but well, we will keep it there. Remove a stack and set the stack, can player use, return true. And these nulls, especially the get a stack, will cause a problem maybe. We will take a look. But now that I have an inventory, and by the way, we will come back and change that in the next video, because in the next video, we will add a proper inventory to the block entity. But right now, we want to take a look at how we can add some stacks into the game and see the library that I have that produces some useful slots there. So we say this dot add a slot. Now, as you see, it asks for a slot. We say new slot, and it comes from Net Minecraft screen slot. It needs an inventory. We already have an inventory. Then it needs an index. Now, this index is related to the index of the slot in your inventory. Make sure that these indexes are the same between your inventory in the block entity and here. So we say, I don't know, 0 maybe, and then needs the X and Y. Now I want to add this input slot first. That's my first priority. You may want to choose something else. It's up to you. But for me, this input slot is my first priority. So I want to add it inside 113 and 29. So 113 and 29. Now let's see if I use the hot swap. It will not work because I already used an interface being implemented and I added a lot lots of things here. So let's rerun the game and see the result. And hopefully we won't get null point exception because of this guy. If we get the null point exception, sorry, we can't show it in the graphic user interface right now. But I will continue the video showing different ways of adding some slots, because in this video we really want to talk about slots and see how we can have our own custom slots. Now let's hope that we don't get a null point exception and crash. And actually we got the null point exception. Now if you take a look, it happens in the renderer line 71, and if I go up, I only see main at Java and nothing else as the code lines that will direct toward my problem. Okay, now I can't solve anything here because I don't see any proper direction toward my block entity. And I assume that line 77 would be the culprit, but in my stack trace, I don't see the block entity. So this is main, this is the screen renderer, this is the screen renderer, and main. Now you see the message itself is useful. It says cannot invoke is empty because item stack is null. Now let's see, is empty is always returning false. However, when we want an item stack, it's actually here. Okay, so I will say new item stack of, actually I think, do we have empty? Yes, item stack.empty. So we don't return null, okay? And each time I'm working with remove, I will return item stack.empty, set the stack, and others can stay as it is. And is empty, let's return true now because, well, all of the item stacks are empty. Now let's rerun the game. Hopefully this helps us to at least show this stacks and see what we can do. Okay, fingers crossed. Here we go. We do have our interface, and here you see that I have a slot. Although when I'm putting items in it, they get vanished because, well, guess what? I'm returning empty there. Now, we just want to add more slots into the game. The process for a vanilla slot is just this. You go and add more slots, and each one of them uses their own coordinates, okay? However, what if I want a single slot being special? For example, the energy slot should accept nothing other than the energy upgrade, okay? We don't want to put speed upgrades there, or I don't know, bucket of water here. This slot is dedicated for energy upgrades. This is the proper way of adding any slot in vanilla. However, if we take a look at the slot class, we see that it's actually having a method that lets us override the validity, and that is can insert. This is returning true by default. So here we are asking if can insert an item stack into the slot. So if we want to, we can add a class, and let's call it gem cleaner input slot. Okay, and we will extend this from the vanilla slot. Of course, it says that now create the constructor, and that's all in there, but we can say can insert, and here we can check, for example, return if the stack dot is of something. For example, mod items, let's go dot, I don't know, gem citrine. So if we are putting a gem citrine into this slot, it will accept it. If the item is not the citrine gem, it will not accept that. Or for example, we can check if it's in a tag, and again, the same deal. So if we want to have some inputs that are dedicatedly accepting one or two items, we can use this can insert override. For example, let's create a new package and call it slot. And here I will add new types of slot. So let's put this input slot here and do the refactor and add a new slot, and this will be water bucket slot. Okay, and again it will extend slot, and we will add the constructor, and inside can insert we just return if the stack dot is of items inside Minecraft dot bucket, and we want the water bucket. So now we have a slot that only accepts water bucket. Adding these slots to the interface is really easy. Let's add a new slot, but this time instead of slot, we go with water bucket slot, okay? And again, we want to add it to the inventory. However, now the index will be changed, so I will use the index 1. And for the x and y coordinates, we need this one that is 40 and 18. So 40 and 18. And guess what? We already have our second slot. Now, in my own library, I have something that is called predicate slot. So I can say add a slot and new predicate slot. Let me see, why can't I find it from my own library? Oh wait, I know why, because I didn't reference the J inventory yet. So if I come back to the build.gradle, yes, we didn't reference the J inventory yet because J inventory is not ready to be published. However, in a week or two from this video, it will be ready. So let's open the J inventory with IntelliJ. This is J inventory library. Ignore this README. The wiki and README is a work in progress. Now, if I look into Java, I see this is slots, and you see that I have limited tag, not tagged, output, predicate, and tag. Let's take a look at the predicate because this is the mother of all of these. And as you see, it asks for a predicate. Now, if you know Java, you would know that predicate is a special type of class that will have a method called test, and it will test a condition. If the condition is met, it will return true, otherwise it returns false. So in the constructor, we just send in a predicate, and in here we can say that, hey, we want the can insert from the inventory as the predicate, because in here, instead of any inventory, we are sending simple inventory, and inside the can insert, we are overriding it with the predicate.test. Now, if I want to show you an example of it, just open any other slot class that we have. So let's go with the output slot. As you see, it's an extension of predicate slot. And here we say that for any item stack, we don't care about the item stack, just return false. And this means that the can insert will always fail and return false. So the output slot will never accept any item. We can put items in there programmatically, but inside the user interface, we can't right click and put any item there. Now, the tagged slot has a predicate that says, hey, if item stack is in the tag. Now, if I want to add any other condition here, I can say, for example, item stack dot count. I'm not sure if it can work before importing any Gradle project, is, for example, less than 3. So this slot will accept only the items that are inside the tag and up to 3 of them inside the stack. So if the item stack count is less than 3, it will accept it, otherwise it won't. And here I think I can accept the count from the slot, but right now I can't do anything because the project is being opened, and well, guess what? The Gradle is building itself. So without Gradle project, we don't have IntelliSense or anything else. Anyway, the bottom line is that using something like this, you can really make your slots be very powerful. Now, if I want to come back here and show you an example, I will replace that slot myself. So I will have the predicate slot. Let's get it from the inventory, and I will just copy it and paste it. So we go with new Java class, and that is predicate slot. And here I will just copy and paste the whole class because, oh, there we go. And of course, we need to import few things like predicate for Java and the slot for Minecraft. And this should work now. If I want to, I can add a new Java class. And here, let's say that we want our energy upgrade slot. Now, we will extend this from the predicate slot. Of course, we need to add the constructor. And here I will go with the predicate. And instead of the predicate, I will remove that. I will create item stack lambda. And here we say item stack dot is of, for example, mod items dot something. And here I would go with, I don't know, for example, slot disabled as temporary measurement. And now I want to have the slot count items in the slot. So let's take a look at the structure of the slot class and see if we can find anything. Can insert, we are actually not interested into that. Get a stack. So it will present the stack of the slot as it is right now, and I will say and get stack that is related to the slot dot get count is smaller than 2. So I can add one more on top of it and it will become 3. Okay, now get stack, why are you not behaving? Is that, oh, we can't call it before the super class. Okay, this is troublesome here. So no matter what, we get it here, and then I can say can insert, yes, we call the super and get stack dot get count is smaller than, I don't know, 3. Why is it working? Because the super is actually calling this predicate thing. So we are already testing the predicate, and after the predicate that says it should be this type of item, we just get the count of the items inside our slot and we make sure that it's less than 3, means that we still have 2 items there. We can add one more, and the moment we add one more, we become 3. So this part will be failed and we can't go above 3. So this is an example of how you can utilize something like the predicate slot and go on top of it and add more conditions to have more complex system. For example, one of those complexities that I produced can be seen inside limited tag slot. So here I'm saying that, you know what, I need a predicate of item stack that should be in the tag list but shouldn't be into another tag list. For example, it should be, I don't know, stone crafting block, and it shouldn't be, for example, a nether block, okay, or I don't know, a deep slate block, and anything like that. I can use combination of tag keys here, and of course, if I want to use this system, I can have an integer here, a limit for the energy, and here I will have a private final int, and we call it limit, and inside the constructor we say this dot limit equals to the limit we sent in, and finally here we say less than limit because we want the limit to be 3, and that's it. We can do as many things as I want. If you need to get the stack inside the slot, you can't add it in the constructor, you add it in the can insert. But if you want, for example, I don't know, a special tag, well, we have in tag or off tag, something like that, as our own library, and you see that this is the boilerplate of everything in my library for the slots, the predicate slot, and everything else is sitting on top of the predicate slot, and you can go as complex as you want to. Now, I will nuke every type of a slot that I have, but right now, let's say that I want a new energy upgrade slot. Now here we add the inventory and we want the coordinates. So the coordinates is this guy, 8 and 28. So this is x is 8 and y is 28, and then the index comes first, so this is index 2. Then we have the limit. So as you see, we should have a limit, and the limit is 3. Okay, and that's it. So I have my own special slot that only accepts one type of item and up to 3 of it inside that slot, not more. This is how you add your slots to the game. So if you just want a vanilla slot that can accept everything, that's it, just new slot. Otherwise, you need to provide some functionality for your slots inside your custom class. If you mimic this predicate slot or actually use my JInventory library, in few weeks it will be up and running. Be my guest. You can have as many different things as you want, and that would be easily achievable to have any sort of complex logic related to your slot. Just overwrite that can insert and put your logic there, and like any other Java class, you can now add parameters, you can add attributes, you can use them. Who cares? You can do all of that. You can even accept the block entity and do anything you want on that block entity as the logic for that can insert. I don't know, but you can do that. If you like these videos, please subscribe to the channel, hit the like button, and turn on that bell so that when I publish a new video, you will get informed. Have fun, everyone. Bye.